Hello, welcome to the Argo course. My name is Mohammed and I'm very happy to be here. In this session, I want to talk about blue-green deployment strategy. It has multiple features and options, and I'm going to explain each of them. But for now, there is an important question. How does Argo-rollouts work? Similar to the deployment object, the Argo-rollouts controller will manage the creation, scaling, and deletion of replica sets. These replica sets are defined by the spec.template field inside the rollout resource, which uses the same pod template as the deployment object. These are the directories related to this course, and one of these directories called Argo-rollouts blue-green. I click on it. We have two different directories here. I'm going to explain both of them, but for now, let's click on blue-green manifest and open rollout.yaml. As you can see here, the kind of this rollout is rollout, and the name of this rollout is blue-green deployment. And we have a field here called spec.template. This is the most important field of this rollout, spec.template. When the spec.template is changed, that signals to the Argo-rollouts controller that the new replica set will be introduced. The controller will use the strategy set within the spec.strategy field in order to determine how the rollout will progress from the old replica set to the new replica set. Once that the new replica set is scaled up, the controller will mark it as stable. We are using blue-green strategy for this rollout. If we change any items under a spec.template field, the new replica set will be created. For example, if we change the name or the tag of this image, the new replica set will be created. Or I decide to change the value of this environment variable, and it will be created. The new replica set will be created because of this new change. So when I change any elements and any items under a spec.template field, the new replica set will be created. Okay? This is about Argo-rollouts flow. I want to explain the blue-green strategy. Very good. We have two different services in this strategy. The first one is active service, and the second one is preview service. And also we have a rollout for our application. This is the rollout for our application. In this rollout, we are using a label called app equals blue-green deployment. And we are using an image called blue-green v1, for example. This is the spec of our rollout. This is the spec of our application. And these two services point to this rollout. Active and preview point to this rollout, because these two services are using a selector like this. Selector app equals blue-green deployment. So these two services point to this rollout using this label and using this selector. Very good. After a while, we decide to release the second version of our application. Therefore, we change one of the items under the template, and a new replica set is created for version 2. Let's imagine that we decide to release the second version of our application, and because of that, I modify the name of the image from blue-green v1 to blue-green v2. This is the spec of the second version of our application. In this time, active service still points to version 1, and preview points to version 2. Because of that, I remove preview from here. So active service is pointing to version 1, like this, and preview service points to version 2. But the question is, how does Argo-rollouts know to point the preview service to the new replica set and active service to the old replica set? In this time, we have two different replica sets. The first replica set has a unique hash. For example, blah, blah, blah. This is the unique hash of the old replica set, and active service points to this version 1. And we have a new replica set for the second version of our application. And the unique hash of this replica set is like this. And preview service points to the version 2. But how Argo-rollouts know to point the preview service to the new replica set and active service to the old replica set? This is an important question. The rollout controller ensures proper traffic routing by injecting a unique hash of the replica set to these services selectors. Because of that, Argo rollout controller modify the service selector and add a new selector for these two services. The new selector is like this: pod template hash, and its value is like this. And for the preview service is this. So Argo rollouts Argo-rollouts controller modify the services selectors and add a new selector for these two services. And the value of the new selector is the unique hash of the replica set. This is the unique hash related to the old replica set. So active service points to the version 1. And this is the unique hash of the new replica set. Therefore, preview service points to the new replica set. So it was about preview service and active service and blue-green strategy. In this situation, our users are using the first version of our application. If we want our users to use the second version of our application, we can promote the rollout. If we promote the rollout, Argo-rollouts controller will modify the selector related to active service. In this time, the Argo-rollouts controller will remove this unique hash from active service selector like this and replace it with the unique hash related to the new replica set like this. In this situation, both of these services point to the second version of our application. Because of that, I remove active from here and add it here. I type active. So there is no service to point to the first version of our application. But what about version 2? Active and previous services point to the second version of our application. Because we promoted the rollout. Very good. Let's go back to VS Code. I want to show you how blue-green strategy works with several examples. But before that, I should mention that we will be using our own custom image for the examples of this session. As you can see here, these are directories related to the Git repository, and one of these directories called Argo-rollouts blue-green. If I click on it, we have two different subdirectories, and one of these subdirectories called BlueGreen app, and this is the application of this session. We are using Flask to run the application. But what is the application? I'm using two different HTML files here to show you two different versions of the application. The first version of the application is app-v1.html. If I click on it, we have a very simple web page with version 1 of the application, and also the background of this web page is blue sky. This is version 1. And app-v2.html, this is version 2. This is the second version of the application, version 2. And also the background color of this web page is green. So these are two different versions of the application that I want to use. And also we have a Python script. We are using Flask to run this application. As you can see here, we are using a render template here, render template, to render these two different HTML files. This is the name of one of these HTML files. But we are using an environment variable called HTML name, and it has two possible values app-v1.html or app-v2.html. So if you want to run this application, you have to define a variable called HTML name and give it a value from these two possible values that I said earlier. I have already created the image, and this is the Docker file related to this application. You can build the image of this application based on the directory of Blue-Green app. And also, if you want to run a container from this image, you have to define a variable with -e option for your container to define a variable called HTML name and give it a value app-v1.html or app-v2.html. Okay? So we need to define a variable called HTML name and also give it a value. If we want to run this application, if we want to run a container from this image, if I type the Docker images grep Blue-Green, you can see that we have an image called Blue-Green, and this is the image related to this Docker file. And if I want to run a container from this image, I have to define a variable called HTML name and give it a value. Very good. Another directory is Blue-Green manifest. If I click on it, we have two different manifests here, ingress and rollout. These are the manifests that we need in this session for the examples. Let's open rollout.yaml. The kind of this manifest is rollout, and the name of this rollout is Blue-Green deployment. The number of replicas is 4. And we are using a label for this rollout called app equals Blue-Green deployment. The name of the container of this rollout is Blue-Green, and the name of this image is Blue-Green 2. This is the image that we want to use for the examples, Blue-Green. And this image is available in my local machine. So we don't need to pull it because this is available. Therefore, I'm using image pull policy equals never. As I said earlier, if I want to run a container from this image, if I want to run a pod from this image, we have to define a variable called HTML name and give it a value. Because of that, we are using env, and the name of the variable is HTML name, and its value is app-v2.html or app-v1.html. And this is the default port of the application or the container. This is the default port for the Flask. The strategy is Blue-Green, and we are using 3 different options here. I commented out these lines, but I want to use all of them in the following examples, so don't worry about them. The first one is active service. This is the name of the active service that we want to use. Rollout Blue-Green active. As you can see here, this is the active service. Its name is Rollout Blue-Green active, and we are using a selector for this service to point to this rollout because its selector is app equals Blue-Green deployment. And the name of the preview service is Rollout Blue-Green preview. And this preview service is pointing to this rollout because it's using this label app equals Blue-Green deployment 2. And also we have another option here called auto promotion enabled equals false. But what is that? The auto promotion enabled will make the rollout automatically promote the new replica set to the active service once the new replica set is healthy. This field is defaulted to true if it's not specified, but we are using it to set it to false. So if we want to promote this rollout, we have to use it manually. Very good. Then the next file of this directory is ingress.yaml. I'm using Nginx ingress controller to point to active service. As you can see here, the backend service is Rollout BlueGreenActive, and the domain name is bluegreen.demo. I'm using this domain name in my etc host. If I type etc host here, this is the domain name that is pointing to my localhost address. Okay. Let's go to create the first example. But before that, I type kubectl argo-rollouts dashboard to see the dashboard of argo-rollouts. I copy the path and paste it here. This is the default dashboard of argo-rollouts. Okay, very good. Let's create two different files. The first file is this. I copy the content. Let's create a file called rollout-1.yaml because this is the first example. Rollout-1. Very good. We are using three different options: preview service, active service, and auto promotion enabled equals false. And let's create an ingress. Copy the content and paste it here. Very good. First of all, let's apply the rollout kubectl apply-f rollout-1 into BlueGreen namespace. kubectl create ns BlueGreen and then apply it. Okay. Three different objects have been created: the rollout, BlueGreen active service, and BlueGreen preview service. If I go to the dashboard related to Argo rollouts, we have a namespace here called BlueGreen. Yes, this is revision 1. This is the first version of our application. And the number of replicas of this application is 4, as you can see here. Both of the services are pointing to revision 1 and this replica set. But before that, let's apply the ingress, apply-f ingress.yaml-n blue green. Okay, I apply it again. Very good, and this ingress has been created. So if I type bluegreen.demo here, bluegreen.demo, http bluegreen.demo. As you can see here, this is version 1 of the application and the background color is blue. Okay. We have a replica set here. kubectl get res-n blue green. This is the replica set related to the version 1. Let's go back to the VS Code. As you can see here, the selector of these two different services, I mean active and preview, is app blue-green deployment. But in this situation, for the first version of the application, Argo-rollouts controller is responsible to add a selector to these services. If I type kubectl get svc-n blue green, these are two possible and two available services in blue-green namespace. I type kubectl get svc rollout blue-green active -n blue green -o yam. Yes, we have a new selector, rollouts pod template hash. As I said earlier, Argo-rollouts controller is responsible to add a selector to these two services. This selector has been added by Argo-rollouts controller. This selector has been added by me, but this selector has been added by Argo-rollouts controller. The key is rollouts pod template hash, and the value is the unique hash of the replica set. If I type kubectl get rs-n blue-green, yes, these are the same. It was about active service, but what about preview service? Rollouts blue-green preview. Yes, the preview service is pointing to the replica set related to the first version of the application. Okay. Let's modify rollout 1. In this time, I want to modify one item under spec.template to trigger Argo-rollouts controller to create a new replica set for the new version of the application. Because of that, I want to modify the value of HTML name from app-v1 to app-v2.html. I save it and apply it again. And the rollout has been configured. If I go back to the dashboard, this is revision 2. This is the revision 1, but this is revision 2. We have a new replica set, and this is the unique hash related to the replica set of the new version of the application. And the number of replicas is 4. But in this time, only the previous service is pointing to this revision. Active service is pointing to the old replica set and is pointing to revision 1. If I type kubectl get svc rollout blue-green active, the active service, 64, and this is 64. It means that active service points to revision 1. But what about previous service? 47. 47. It means that previous service points to revision 2. Argo-rollouts controller is responsible to modify this selector. So in this time, active service points to revision 1, and also previous service points to revision 2. As I said earlier, the auto promotion enabled is false in this example. So if I want to promote the rollout, I need to do it manually. As you can see, BlueGreen.demo is in version 1 because the backend service of this ingress is active service. So now I'm going to promote the rollout. I'm going to promote this rollout, and active service will point to the revision 2 of the application. How can we do it? We can type kubectl argo-rollouts promote rollout. This is the name of the rollout, BlueGreen deployment. Blue green. kubectl argo rollouts promote blue-green deployment. Very good. And the rollout has been promoted. So now if I go back to Argo-rollouts dashboard, as you can see, a stable service, active service points to the revision 2. And revision 1, if you can see here, revision 1 is terminating because there is no service to point to revision 2, to revision 1. Previous service and active service, both of them are pointing to revision 2. If I type kubectl get-ref-n blue-green, this is the new replica set and its replicas is 4. And the old replica set has been scaled down. If I go to active service is now pointing to revision 2 as well as previous service. So if I refresh this page, yes, this is version 2 of the application. The backend of this ingress is active service. So now active service is pointing to revision 2 because we promoted this rollout manually. Very good. Let's back to the example. Rollout1.yaml. In this time, I want to remove or comment this line. Auto promotion enabled equals false. Auto promotion enabled is true by default. It means that when I release the new version of the application, Argo-rollouts controller will promote the rollout automatically, and we don't need to promote the rollout manually. Because of that, I comment this line, auto promotion enabled equals false. First of all, let's delete the previous rollout from the previous example. Very good. And let's modify the value from app-uv2.html to app-uv1.html, and auto promotion enabled is disabled. Let's apply this rollout and go to Argo-rollouts controller dashboard. We need to wait for the new rollout. So, okay, this is revision 1, and both active and previous services point to the replica set related to revision 1. In this time, I decide to modify app-v1 to app-v2. In this time, we decide to release the new version of our application. In this situation, active service will point to the new replica set related to the new version of the application, and we don't need to promote the rollout manually. Argo-rollouts controller will do it automatically. So when I type kubectl apply, let's go to Argo City dashboard UI, and as you can see here, there is no service to point to revision 1, and the revision 1 will be scaled down in 10 seconds. And both services point to the new version. And Argo-rollouts controller did that automatically. It was about auto promotion enabled equals true. This is true by default. Very good. Okay, let's go back to the rollout. The auto promotion enabled is true by default. Very good. The next option is auto promotion seconds. This line, auto promotion seconds. The auto promotion seconds will make the rollout automatically promote the new replica set to active service after the auto promotion seconds time has passed, since the rollout has entered a paused state. If the auto promotion enabled field is set to false, this field will be ignored. The auto promotion seconds is 0 by default. It means that Argo-rollouts controller will promote the rollout without any delay seconds. Okay? But in this time, I want to set auto promotion seconds and set a number for that. For example, 30 seconds. It means that when I release the new version of the application, Argo-rollouts controller will promote the rollout in 30 seconds or 20 seconds. 20 seconds. Let's do that. In this example, I want to release the new version. For example, we want to modify from app-v2 to app-v1 again. This is the new version for the application. For example, that we are in revision 2, as you can see here. So I type kubectl apply. Let's go to Argo-rollouts dashboard. The previous service points to the new revision, but the active service points to the old revision. Let's wait to see how it works. I mean, auto promotion seconds. Yes. So now active service points to the revision 3 after 20 seconds. So when I refresh this page, we are in version 1 and in revision 3 of Argo-rollouts. And revision 2 has been scaled down, and the revision 2 is terminating. it was about auto promotion seconds. The next option is preview replica count. This line, preview replica count. The preview replica count field will indicate the number of replicas that the new version of an application should run. If you see here, my revision 2 replicas was 4, and the new revision was 4. Okay? Once the application is ready to promote to the active service, the controller will scale the new replica set to the value of the expected replicas. The rollout will not switch over the active service to the new replica set until it matches the spec.replicas count. If I want to use preview replica count, for example, I want to have 3 replicas from the new revision. When Argo-rollouts controller decide to promote the rollout, the number of replicas of the new revision will be back to expected replicas, 4. But before that, the number of replicas for the new revision will be 3. And after the promotion, it will be 4. This feature is mainly used to save resources during the testing phase. If the application doesn't need a fully scaled up application for the test, this feature can help save some resources. In this example, preview replica count is 3. It means that when I release the new version, the number of replicas of the new version will be 3. And after the promotion, it will be 4. Let's do that. I change app-v1 to app-v2 to release a new version. Very good. As you can see, the revision 4 has 3 replicas. It's not 4, it's 3. And after the promotion, the number of replicas will be 4. But for now, it's 3. After 20 seconds, the active service points to the new revision, and then the number of replicas is now 4, because spec.replicas is 4. But before the promotion, the number of replicas of the new version is 3, because the number of replicas in preview replica count is 3. Okay, it was about preview replica count. So if I refresh, we are in version 2. The next feature is scale down delay seconds. This line, scale down delay seconds. The scale down delay seconds is used to delay scaling down the old replica set after the active service is switched to the new replica set. Its value is 30 by default. It means that when I, for example, modify the value and then apply it, if I go to Argo-rollouts dashboard, after switching active service to the new revision, the old replica set will be scaled down in 30 seconds by default. After 30 seconds, revision 4 will be scaled down. I wait for that. Yes, revision 4 is terminating after 30 seconds. But in this time, I want to change this value from 30 to 10 seconds by default. I want Argo-rollouts controller to scale down the old replica set after 10 seconds. So, if I modify value from app-v1 to app-v2 and I apply it, this is revision 6, and after 20 seconds, the active service will point to the new revision because of auto promotion seconds. And after that, let's wait for the active service. Yes. And after 10 seconds, revision 5 is scaling down. So revision 5 is terminating after 10 seconds because of scale down delay seconds. Very good. Another option and another feature is abort scale down delay seconds. For example, I release the new version of the application and the preview service points to the new version. After a while, I decide to abort the rollout. For example, we are in revision 6. After a while, I abort the rollout. Because of that, we will back to revision 5, for example. The abort scale down delay seconds. It means that when I abort the rollout, Argo-rollouts controller will abort the rollout after 10 seconds, for example, after 20 seconds, for example. Let's do that. Let's set it to 5 seconds, for example. First of all, let's modify the value. For example, I'm releasing the new version of the application. I apply it. We are in revision 7, and then I decide to abort the rollout. After 5 seconds, the Argo-rollouts controller aborted revision 7, and revision 7 is terminating, and we are in revision 6. Preview service and active service, both of them point to revision 6 because we aborted revision 7, and Argo-rollouts controller aborted the rollout after 5 seconds because we used abort scale down delay seconds, set it to 5. Very good. I mentioned all the options and features related to Blue-Green strategy. In the next session, we will want to talk about canary deployment. Okay, that's enough for this session. Have a good day and see you soon.